Hi everyone, and welcome to our Psych cast today. And today we're going to be talking about the first sense that I want you to get to know in our sensation and perception unit, and this is the sense of vision, right? And of course I do this one first because most of us rely on our vision way more than we do our other senses. This is something called visual capture, right? And we rely on this sense way more than our other ones to figure out our world around us. So how does vision work, right? So this is the eye, obviously, right? And all the different parts are labeled. The parts that we're really going to focus on in this class, right, are the retina, the fova, the blind spot, and the optic nerve. So we're really concerned a lot with the back of the eye. Now, of course, the lens is important because it shines the light on the retina. And then you have your iris, the colored part, the pupil, and the cornea. So, okay, what about the parts of the eye? The pupil is the part in the center that adjusts the amount of light. The amount of light is really important because your eye is kind of like a camera. And if the amount of light isn't right, then of course you don't get the right kind of picture. Okay, so the pupil adjusts for that. That's why your pupils dilate when it's dark in a room because they need to let more light in. The iris is actually a muscle, and that muscle controls the pupil, and it's what gives your eye its color. And then the lens. The lens is the structure that's behind the pupil and the iris, and it actually bends, right, and changes shape to focus things on the retina. So concave and convex, right, physics, to focus images on the retina. And yes, they do flip upside down on the retina when they go into your eye, if you've heard that before. That's true. Okay, but the most important part of your eye is the retina, right? You don't actually see with your eye. You see with your brain. Okay, the brain is what really interprets all the information that's coming in. But the retina is where all that information gets turned into a message the brain can read. The brain can't read light waves, okay? The brain can read neural messages with action potential. So the retina does that job. The retina is a light-sensitive inner surface of the eye. It's on the very back of the eye, and it contains rods and cones. The rods and the cones are what take the light and turn it into a message that your brain can read. Okay, they process the visual information. Okay, if you see here, we have all the way to the back of the eye, we have the rods and the cones, and then you also have some other cells, but you don't need to know about those, right? Particularly, I want you to focus on the rods and the cones. And if you see here, they all converge on the blind spot because that's where there's no retina because the nerve is leaving the eye to go to the brain. So, rods and cones, right? Cones, you have to know, cones are in the center of your eye and they deal with color, right? Cones center color. The rods, you have way more rods than cones, but they're on the outsides of your eye. They are very, very sensitive to light. So they're good in dark light, seeing at nighttime, all of those things. So cones are for color and rods are for darkness and light and different sensitivities of dim lights. Okay, cones, color, center, rods on the outside. And they literally do look like rods right here and a cone. Okay, and as you can see, it's like rod, cone, cone, right? So, there's way more rods than there are cones. Again, see here, right, in the center, look, you have cone, 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 right? And then you start to see you have some rods on the outside, okay? And as you get farther out, you notice how there's like two here, then one, so you'll get more and more rods. So that's why I said it's on the periphery, and the cones are in the center. The center of your eye is called the fova, right, or the center, it's where you have like the sharpest point of vision, right? So where you have the clearest, they call it acuity, or the clearest point of vision. So look, we have cones, color, center, clarity. Bam! All C's. Okay, this is just a picture of what it looks like to get to your brain. So you have the eye, right, rods and cones, through the optic nerve, through the thalamus, Amos, right? And then all the way back to the visual cortex and the occipital lobe. Now, what is color? What is light? What are we actually seeing when we see things, right? So color is just wavelengths, right? If you've taken physics, hopefully this rings a bell. And there's a couple of different ways that wavelengths can be interpreted. So short wavelengths, the distance between one wave and the top of one wave and the other is a high frequency. And then we have long wavelengths, which are a longer distance. And then we have from the top and the bottom of the wave, that's the amplitude. And then, so the higher the amplitude, the brighter the color. So you can have a color that is bright blue or dull blue, depending on the amplitude, or bright red or dark red, depending on the amplitude, right? The way that I remember this is that Smurfs are short, so short wavelengths are blue, and Clifford was a big red dog, so big wavelengths are red. So there's two basic theories of how your eyes see color. The first one is it's kind of like it seems, trichromatic is 3 color, tri-3, right? So they said that every single cone is sensitive to either red, green, or blue, and that those then combine, kind of like your TV set, to make all the other colors that your eyes see. This, go back for a second, is what explains color blindness. So write that down, and we'll talk about that more in class. The other theory of color is not that each cone only has one color, but that each cone has 2 colors. And so when one color is on, the other color is off. And they're in pairs. Opponent, process. So think of your opponent as your pair, right? So when the red is on, the green is off. And the green's like, bam, I'm on. And then the red's like, bam, right? So they're like fighting it out. And only one can be on at a time. So red, green, Christmas. Blue, yellow, Michigan, hail. And black, white. Okay, black and white, we all know they go together. They've always gone together. You'll remember it just fine. Okay, so these are the 2 theories of color. And not one theory is right, another theory is wrong. They're just 2 different ways of explaining color, and they both work, and they both have different reasons why they work. And we'll talk about that more in class. Okay, so that's all for now, Mundelein Psychotics. And remember, psychology is flippin' awesome.